FutureMakers.
Hi, this video is made for educators to guide your learners through a fun experience of building and testing a flying machine. They'll design and build a wind-up flying machine using stored potential and released kinetic energy. We'll explore the role of symmetry and how small design changes can make a big difference. Before we jump into building, let's take a look at our materials. You should have an instruction sheet, which will also double as our fuselage or wings. You'll also need scissors to cut out your fuselage, a set of markers, a sticker sheet for attaching your fuselage, a propeller, a fuselage stick or the base, a rubber band. We're going to grab these three first and build our first version of the flying machine. The first step is to attach the propeller onto the stick. Make sure to align the metal hook with the wooden hook on the opposite end. Push it in all the way and test to make sure it's attached firmly. Next, stretch the rubber band between two fingers and hook it onto the propeller and the other end of the fuselage stick. Time for a test. Will it fly without fuselage? Turn the propeller clockwise more than 50 times to tighten the rubber band. We'll use the lift-off technique. Release the propeller first, lift, and then release the stick. Off, and it will lift off. When you wind your propeller, it stores potential energy in the rubber band. This is called elastic potential energy. When you release the propeller, the rubber band releases what it stored, turning it into kinetic energy. 3 problems could cause your flying machine not to fly the way you want it to. You need to store lots of energy in the rubber band for it to generate lift and fly away. Be certain to wind it clockwise at least 50 times and to look for big bumps in the rubber band. You can always add more energy. If you let go of both the stick and propeller at the same time, the propeller won't have enough time to generate lift, and your flying machine won't be able to fly up like you want it to. You have to release the propeller, allow it to spin and generate lift, and then release the fuselage. What happens when you turn the propeller counterclockwise to the left? It will go backwards, and instead of flying up, it will shoot downwards. Always turn the propeller clockwise to the right to make it fly up. Now let's add some wings. Will this change how it flies? We'll be using this test shape first. Encourage your learners to color it in any way they'd like, but make sure they cut it along the dotted lines. Once you have your shape cut out, attach the wing to the wooden fuselage stick with sticky strips. Make sure to align the stick in the middle and allow the propeller to spin. Avoid sticking the rubber band. It needs to be able to move freely. Try it out. What changed? It's finally time for the most fun part. Your learners will use the design template to draw a wing profile, add color, and cut out their own fuselage. Wings are typically symmetrical, mirror images along a center line. There are light dashed lines printed on the template sheet to follow. To make the machine fly differently, learners can bend one or both sides of their fuselage, causing it to arc or twist in flight. They can experiment and change the tips of their wings to see what effect it produces. What else can you try? Here's some fun ideas and challenges. What would you change to make it fly farther? What would you change to make it fly for a longer period of time? Can you make it fly to the left or right? Encourage your learners to make unique symmetrical wing shapes, different sizes, or different number of rubber band twists, and observe different flight outcomes. Congratulations on building and playing with your flying machine. We make Sparks so learners can keep what they make and take them home. We believe that owning what they make helps them engage, take greater risks, and allow more playful learning to continue in your classroom and anywhere they go. Thanks for watching.
Future